Okay, a really warm welcome to everyone joining us this evening, both in the live Zoom room and those who are following on YouTube and who may be watching this talk later down the road. This is our second EVA alumni talk of the spring 2023 season. We had 4 wonderful talks last fall when we inaugurated this new online talk series, and then 1 talk earlier this spring. And so this evening, we're really delighted to welcome Dr. Julio Rodríguez Larios, who was an EVA awardee in 2019. And so just as a reminder, many of you know that this series is really dedicated to offering a platform to recipients of the European Varela Award program, showcasing not just their research, but also their research trajectories, so where their earlier research project has taken them since. And so really happy to hear from Julio this evening about his particular research project, which was called Investigating Brainwaves During Meditation in Experienced and Non-Experienced Practitioners. So I'd just like to briefly introduce him, and then I will give you the floor. And just as a reminder, in the second part of the evening, we will have ample time for questions and for an in-depth discussion. So if you do have questions coming up, make sure that you note them down, and then we'll have a nice discussion in the second part of the evening. So Dr. Julio Rodríguez Larios is a postdoctoral researcher currently affiliated with Columbia University in New York City. He completed his BA in psychology at the University of Malaga in Spain, his MA in cognitive neuroscience at the University of Maastricht in the Netherlands, and his PhD in biomedical sciences at the University of Leuven in Belgium. His research is focused on the study of the neural basis of human cognition, and he's specifically interested in the role of human neural oscillations, which he usually investigates through the EEG. And so we will hear much more about that and really about the field of neurophenomenology in a more general way. So thank you so much, Julio, for joining us this evening, and the floor is yours.
Thank you, Jonah, for the nice introduction. So yeah, I'm really happy to be here, and I will be presenting the work I did, I think, a couple of years ago, funded by Varela Award 2019, I think. That was a long time ago. Yeah, and as Joanna mentioned, I'm currently a postdoctoral researcher in New York, and this work was done when I was doing my PhD in Leuven. Yeah, so what I investigated basically is whether brainwaves during meditation are different between meditators and novices. So I'm going to try to walk you through this project. Okay, I think my presentation works. Okay, let's start. I would like to start talking about what is meditation, because I think that we use this term in really different contexts, and meditation is an umbrella term, and it involves a wide variety of practices with really different techniques and really different objectives. I like the classification made. Do you see my pointer? Yes, I assume that you do. You see it, right? I like a classification that was proposed by Matko and Selmayer in 2019 of meditation techniques. I actually met Karin in one of the Mind and Life retreats. They propose this classification of meditation techniques based on the level of activation and the level of amount of body orientation. And the meditation practices that we'll be investigating adopt mostly meditation techniques that are around here. So low activation, a lot of body orientation. So this is basically mindfulness meditations. So I would basically ask participants to focus on their breath, on the sensations associated to breathing, and observe their thoughts, right? I will be talking about this type of meditation. I just want to make it clear from the beginning, because I know that there are a lot of types of meditations, and I just wanted to make clear from the beginning that I'm going to investigate only this type. Okay, why did I decide to study mindfulness instead of investigate mindfulness instead of any other type of meditation? Well, really pragmatic reasons, actually. Mindfulness is the most common meditation practice in the West, and this is, of course, really related to the early work of John Kabat-Zinn, showing that this type of meditation practice has some health benefits. And it became really popular in the West. Another reason for investigating this kind of meditation is that it is easier to operationalize compared to other meditation practices. So if you would ask someone with a meditation experience at all to meditate, the instructions of mindfulness are a bit more straightforward. And this helps when you want to investigate changes in the brain associated to meditation. Okay, I hope this is clear. If we talk about meditation, we need to talk about mind wandering. It doesn't matter if you have been meditating for 1 day or 1 year, you would notice that if you try to focus on body sensations associated to your breathing, for example, you would realize that your mind will wander off in thought. So you will experience self-generated thoughts involving memories, future plans, fantasies. This concept of mind wandering has been investigated quite a lot in the last, I would say, 10, 20 years. It got really popular due to the work of these two authors, to a great extent. Osman Woodman Schooler, they have done really cool work about mind wandering. And so now we know that mind wandering, it's more likely to occur during sustained attention tasks. And another reason why it became really popular is because there was some research showing that mind wandering has some negative effects on mood. There was one really famous paper 10 years ago showing this in a really straightforward manner. Of course, it's a bit more nuanced than this, but I think that this is one of the reasons why the research in mind wandering also became so popular in the last years. Interestingly, mind wandering and mindfulness have been conceptualized as opposing constructs. Reduced mind wandering is proposed to, or putatively, mediate positive effects of mindfulness. So there's some people proposing that the reason why this type of mindfulness meditations have positive effects on mental health is because you would experience in general less mind wandering during meditation, but also during other activities, and this has a positive effect on mood, right? In line with this idea, it is true there's some evidence showing that mind wandering is less frequent and maybe less engaging in people that have more meditation experience. Okay, based on this theoretical background, the question that I wanted to answer, and the reason why I decided to apply for this grant, is because I wanted to know whether meditators and novices experience meditation differently. This is something that, I mean, it's something that you could infer, but there's not so much evidence for this. The idea here is that at the end, I'm a neuroscientist, so if we find, if meditators and novices experience meditation differently, we should find difference in both self-reports and brain activity, right? And I'm not gonna develop this idea because, of course, it's I'm sure you're acquainted with Varela's work, but the idea here is that experience and brain activity are not two independent entities, right? So these two these two factors are intermingled, are related, and a really good way of studying consciousness is to combine these two, because they put mutual constraints between them, right? So I wanted to know if meditators and novices experience meditation differently, and my rationale based, of course, on Varela's work was that if this is the case, we should report both differences in self-reports and brain activity. how do I look at brain activity? As Joanna mentioned, I mostly did research on electroencephalography. This is the method that I use to investigate the brain. And electroencephalography has been was invented like in 1929, so it's an old method. Was invented by Hans Berger. The motivation to invent this method was a bit weird. I mean, of course, it was based on some previous reports of brainwaves, but I always like to say this because it's a really funny thing that Hans Berger actually thought that telepathy was a thing, that telepathy was real, and he wanted to demonstrate that, and that's why he invented EEG. Obviously, he couldn't demonstrate that telepathy was real, but he invented a method that has a great contribution for medicine and basic science in the next century, basically. Now we know a bit more about how EEG is generated. We know that this is generating dendrites, this part of the neurons that is indicated here, particularly by extracellular currents. And we are only picking up the activity of a specific type of neuron that is located in a specific way. So it's not that I just want to make clear that it's not that with EEG you can detect any type of brain activity coming from any type of neuron, right? We are limited to really specific neurons that are arranged in a really specific way. Specifically, we think that the EEG is generated by pyramidal neurons that are perpendicular to the scalp. So if you have a lot of these big neurons perpendicular to the scalp, and they are being deactivated at the same time, then they will generate a potential that you can measure from outside the brain, right? And this what we call EEG. Okay, I hope this is clear. Okay, so how do we record and analyze brainwaves? So this is how a EEG cap, this is actually literally, I think, the EEG cap that I used for this study, but this is how an EEG cap looks like. When you record the EEG signal, you see something like this. You see that it doesn't look so pretty, it's a bit of a mess. You have a lot of brainwaves mixed there, you have a lot of noise also mixed. The only way we can differentiate between different brain waves or different like brain rhythms is through fairly complex analytical methods like the Fourier transform. And this method would allow us to decompose the signal in different waves. Okay, so what I show you here in green, it will be like a slow wave, and in purple, a quicker wave with less amplitude. If you put them together, you see something like this. You will need Fourier transform to be able to disentangle these two rhythms. Doing this kind of analysis and other analyses that are based on Fourier transform, we can differentiate between different brain rhythms. Different brain rhythms have been given like different Greek letters. For example, like gamma, if it oscillates more than 30 cycles per second, or delta if it goes between 1 and 4 cycles per second. These brain rhythms have been associated to different functions and different areas, like I would say. Problems with this, I mean, I know this looks like super clear and super nice, like, oh, you get EEG, you differentiate your rhythms, and then each rhythm one function. Unfortunately, it's a bit more complicated than that. And EEG has a lot of limitations. And another thing that I want you to keep in mind when I show you the results is that EEG has a really low spatial resolution, so we know what it happens, but we don't know where. And the analytical approaches are still being developed. So I'm going to show you one specific type of analysis that is like the simplest analysis you can do about concerning brainwaves. But I want you to keep in mind that this is not so easy to interpret, and this is not so straightforward, and we are still developing analytical approaches because this signal is really complex and brain rhythms are really complex. I really want you to keep that in mind. Okay, let me show you just how EEG results look like. So it makes it hopefully easier to show you EEG results after. So this is just a random paper, not random, but paper that I chose just to show you how EEG results look like. So whenever I show you my results, you're not like, what's that? So you normally, what you can do with EEG using this Fourier transform is to get how much of each brain rhythm you have in a specific sensor, okay? So what you normally plot is the frequency. This frequency is telling you how many cycles per second in this rhythm, and the amplitude. The amplitude tells you how much of this rhythm you have in the signal. So for example, here, I don't know if you can see really well, but the point of this paper is that during one specific condition, when they ask subjects to manipulate some objects in mind compared to just keeping the objects in mind, they see increased power in the theta range around 6 Hertz. So this will mean that you have more of this rhythm around 6 Hertz during one condition over the other, okay? So I just wanted to show you this so you have an idea of what is the kind of plot that I'm going to show you and what they mean. Okay, let's go to my study and what I did and why. So I use EEG, I use only 19 electrodes, and I will have 3 experimental conditions: a rest, a meditation, and a meditation with experience sampling. I will have 29 meditators and 29 controls. From the 29 meditators, at least 3 years of experience with meditation practices, and 29 controls had no meditation experience at all. During the meditation condition, they were just, these are the instructions that I use. I took it from a book from Kabat-Zinn. So it's a typical mindfulness meditation. Close your eyes and allow your attention to gently align to the sensation of breathing. Every time you notice that your mind has a wander off your breath, notice what it was that carried you away, and then gently bring your attention back to the sensations associated with the breath. So this is a typical, this is what I mentioned before, right? It's a type of meditation that is really easy to operationalize. Even people without experience can understand what they have to do. Another thing is what they actually do, but yeah. So the meditation with interruption, this experimental condition, I will give them like exactly the same instructions. The only difference is that every few seconds I'm going to be a bit annoying and I'm going to interrupt your meditation and ask you, what were you doing? This is what you call experience sampling. Has been used to investigate mind wandering in general, doing different tasks, not so much during meditation. There's some studies, but not so much during meditation. And I will ask where was your attention? And then you will have to answer some questions after. Like you will report whether your attention was on the breath or whether you were mind wandering. And then there were some questions that will follow, like about your level of confidence about your answer. Also, what was your level of focus? What was your level of engagement with the thoughts? We have like several questions because we want to know whether the experience of meditation was different between meditators and novices. Okay. So if we just look at the self-reports, if we just look at this experience sampling, what do we see? We already find quite interesting stuff. We see that, as expected, meditators have a greater proportion of breath focus trials. That means that they report more often that they were focusing on their breath. They also report a greater level of focus. So after they report that they were focusing on their breath, we ask them, what was the level of focus? And then they have to rate from 1 to 10. So they also report greater level of focus. All these questions, by the way, were answered on the computer. We didn't ask them directly. We don't have like one person they're asking every few seconds. Another interesting finding, of course, is that controls, so novices, people without meditation experience, just tend to report more mind wandering, and they also tend to get more engaged with the mind wandering episodes. Okay, so it seems that the experience of meditation is different between meditators and controls. Is this accompanied by brain changes? Well, let's see. I will analyze EEG. I'm going to show you just part of the results because I did a lot of analysis of this data and I estimated a lot of parameters, and I just wanted to stick to the kind of the simplest type of analysis that you can do. if you want to know more about it, the paper is published, and you can have a look at it and read about different parameters and a more comprehensive picture of what we find. But today I'm just going to focus on this parameter that is raw power. That is the one that I explained to you before. So I'm going to assess how much of each rhythm you have at each frequency, right? This is what I showed you before, the frequency spectrum, and the raw power is going to tell you like how much power you have at each frequency. And I'm going to compare this between meditation and rest, and mind wandering and breath focus conditions. I would do this per group so we can see if there are any differences between groups. The mind wandering and breath focus conditions are the ones that I obtained with the experience sampling that I showed you before. Okay, let's see what we get. So when we compare meditation and rest, let me walk you through this big and complicated plot. So here I'm showing you the frequency spectrum. This is what I told you that means how much of each rhythm at each frequency you have. And I show you this for meditators and controls during meditation and rest. Okay, meditation in red, rest in blue. What I'm showing you here is the difference between meditation and rest per electrode and frequency. Okay, electrode in the y-axis, frequency in the x-axis. More blue means that they have less power during meditation compared to rest. Yellow means more power during meditation compared to rest. What we see here is that in meditators, but not controls, we see a significant decrease in the power of upper alpha and beta rhythms. As I said, like we give, depending on the frequency, we normally give names to different brain rhythms. And the ones that are between 9 and 30 hertz, we call alpha and beta. Okay, this is just a name that we give to this rhythm. So we see decreases in alpha and beta rhythms during meditation compared to rest in meditators, but not in controls. Okay. What happens when we compare mind wandering and breath focus? Interestingly, when we make this comparison, we only find a difference in controls, but not in meditators. And we find a difference in the opposite direction. So during mind wandering, you had more alpha beta power. So rhythms in the alpha beta range are more prominent during mind wandering compared to breath focusing controls. But in meditators, we don't really see a difference between mind wandering and breath focus. So long story short, meditators report reduced mind wandering, increased level of focus during meditation practice relative to control, something that we would expect. Interestingly, the brain correlates of meditation differ between meditators and novices. Again, we find this decrease in EEG alpha power in meditators, but not in controls. And the brain correlates of mind wandering during meditation also differs between meditators and novices. In this case, we see increased alpha beta power during mind wandering, in novices, but not in meditators. How do we interpret these seemingly complicated results? The way I interpret this, I think that the reason why we see differences in the brain between meditation and rest in meditators, but not in novices, is because of the high levels of mind wandering in novices. And this is supported by self-reports, right? This is why we try to combine, I think it's for the study of consciousness, why it makes a lot of sense to combine brain data and experiential or self-report data, right? It would make sense that novices, people that have no experience with meditation, they're going to mind wander more during meditation. And we show this with self-reports, right? If they're mind wandering more during meditation, if they're getting more distracted, at the end, the brain state during meditation and the brain state during rest is not that different, right? Because we assume that rest involves some self-generated thoughts and mind wandering. So the reason why I think that we see differences between meditation and rest in meditators, but not in novices, is because novices show so much mind wandering during meditation that it's at the end not so different from rest. On the other hand, meditators, you can expect that, we report this with self-reports, would have way less mind wandering, higher levels of focus, plus other factors, right? Like also you could also expect lower levels of arousal. Okay. Another interesting question is, why do we see differences in the brain between mind wandering and breath focus in novices, but not in meditators? I would explain this by the low levels of mind wandering meditators. We report that meditators show really few trials. It was really hard to catch meditators mind wandering during meditation. Remember that we give them like between 30 and 90 seconds between probes every time. So we interrupt them every minute almost. So it was really hard to catch mind wandering meditators. And I think this is why we couldn't find a difference between mind wandering and breath focusing meditators, because you had really little mind wandering. And when you had mind wandering, probably they were less engaged with the mind wandering episode, and maybe it would last less, would be less intense. And this, of course, would be reflected in brain activity, right? Long story short, I think I answered the question I wanted to answer. And I think that this data supports the idea that meditators and novices experience meditation differently, and that this is reflected in electroencephalography. Okay. How do I interpret the EEG changes? So we see changes, at least I show you only the changes that we saw in alpha beta oscillations. Why do we see specifically these changes here, right? Well, alpha beta oscillations are thought to reflect cortical inhibition. So, for example, I mean, a really illustrative example of this is what we call the Berger effect, right? So if you close your eyes, you will see alpha oscillations emerging in your visual cortex because you are not using the visual cortex. Sorry, got a pop-up, yeah. So there is a lot of theories, or I would say like the most dominant theory proposes that alpha beta oscillations will be reflective of an area not being active, not being processing information. And there's quite a lot of evidence for that. I think it's one of the most convincing theories about EEG oscillations that are allowed, I have to say. So what this would mean in terms in the concept of meditation? Well, what I think is that during mindful states in which you're paying attention to your body sensations associated to the breath, this is the type of meditation that I'm investigating. In those states, areas of the brain that process that information that is coming from your body sensations need to be active, need to activate, need to do information processing. And therefore, you would expect that brain waves in this range are less likely to show up. Of course, this is just an interpretation, but this is the way I interpret these results. Future direction. So what do I think that it would make sense to do after this study? Or I think there are two ways to go. I think that I have done a bit more of the fundamental research after this study with my postdoc, and I just decided to go for the fundamental EEG research because I noticed that we know really little about EEG. But what we need to know is which brain rhythms change during meditation and why. And for that, we need to know how many brain rhythms are there and what are they doing. And we don't know that yet. So there's a lot of fundamental research to be done. My main issue with meditation research is that during my PhD, I ran a couple of studies related to meditation. And the problem is that when you look at the literature, it's extremely inconsistent. Like if you would check what is the role of alpha oscillation meditation, you will find studies in different pointing to different directions. And the reason for this is that the different studies investigate different meditation practices, techniques, and they do different analysis. Really important what I said before. Analytical techniques of EEGs are being developed and they change over time. If you run different analysis that maybe doesn't control for certain factors, you will get different results. So the only way we could ever agree on what are the EEG correlates of a specific type of meditation is by doing open science and sharing data, right? We need more open data. At some point, we might have like hundreds and hundreds of EEGs from different meditators, from different meditation traditions. We can apply different types of analysis, and then we can actually agree on what are the EEG correlates of meditation. In line with this idea, I have to say that the data that was acquired during this project, we shared, and you can have the link. You will have the link in the article, so we can contribute to this. I think this is, until we don't do this, I think we'll never know we will never agree on the EEG correlates of meditation practice or a specific type of meditation. Another line of research that I think that I find interesting, I haven't done a lot of it myself, but is to do a more translational research. So based on what we know that the brain changes during meditation. We know that the brain activity is different in people with and without experience. Can we use this knowledge to improve meditation? One way of doing this, and I mean, I would love to get your feedback on this, because I mean, you maybe don't see a point of doing this, but one way of doing this is through neurofeedback. I don't know if you have heard about it, but neurofeedback, it's basically a technique that allows you to make a specific stimuli, for example, a sound or an image, contingent to EEG or brain activity. You don't have to do with EEG, you can do with other methods. So an example of a neurofeedback paradigm would be, I use a EEG while you meditate, and then based on your EEG activity, I can detect when you're getting sleepy or when you're mind wandering, and then I can send you like a sound, a little sound that will allow you to notice that mind wandering and go back to your breath. This would be one application of neurofeedback. I think it would be interesting to see if this can be done. There are companies that are offering this kind of service. Of course, they don't do a lot of open data, and we don't really know what they're doing or whether their algorithm actually works, because they don't share it. But I think it could be interesting to do in the future. I'm looking forward to see what you think about this. Okay, so I'm done. It's pretty early because I thought it would be nicer to discuss a bit about this. I would like to thank Professor Catalards. She was my supervisor in my PhD. She was extremely supportive about this project, and I'm extremely thankful for that. I also would like to thank Eduardo. Eduardo was a student that was contributing to our research a lot, and then we decided to hire him as a research assistant to work on this project, and he did most of the data collection. He did a great job, and yeah, that's why I'm also really thankful. And of course, Mind and Life Europe that made this project possible. I think that is a really nice initiative because it allows really young researchers to be the principal investigator of their own project, and that is not so easy to get that opportunity. So I'm extremely thankful to Mind and Life for this. I added the references in case anybody's interested in digging in the presentation. Please drop an email. I would be really happy to share the presentation so you can have a look at the papers and figures in depth. And yeah, and that's it. Thank you very much, and I'm looking forward to discuss if you have any questions.
Thank you so much. This has been a great both introduction, but much more than an introduction to the field, I think, for many of us. I'm sure it'll prompt some really interesting questions, especially about the aspect that you ended with, sort of the future directions and different ways in which we could go, and maybe also some of the impediments to moving forward in those directions, like you mentioned, open data and open science. So I see, Annie, you've got your hand raised. I'm just wondering if before we turn to you, I'd love to get your question in just a minute, but just if we could hear maybe a little bit more from you, Julio, about just your initial motivations for entering into this particular approach to neuroscientific research, because I have to imagine that even though it was, quite recently in 2019, you were taking a rather unusual approach in the sense that you were following the neurophenomenological tradition in some ways, rather than what may have been perhaps the norm in some departments. So I'm just curious, what was the motivation, and did you encounter maybe some challenges along the way?
Yeah, I think that, the motivation was that, I know it sounds really simple, but it kind of made sense given my background. So I studied psychology in Malaga, and during my bachelor there, I had I remember my first internship was in a hospital where they used mindfulness, right? And then I developed this interest for meditation. But I also had this interest in parallel about neuroscience. So I started to do some EEG work. Then I continue my master's and PhD. I specialize in EEG, neuroscience, more like the technical details and stuff. And then it's when I encountered the work of Varela. That was last year of bachelor, first year of master, and Evan Thompson. But Evan Thompson, I think that was the two authors that changed my way of thinking about these things the most. And then I realized that something like contemplative practices could also not be used, could only not be used for health purposes, but also to do some basic science. And that was kind of a discovery for me, right? And then the reason why I decided to go in that direction is that's why I say that it just made sense, because it's literally putting everything I found interesting together. So I like basic science. I like contemplative practices. After reading the work of Varela, I was like, oh, okay, that makes sense. You can put these two things together, combine experience with objective brain data, and see if you can make sense of it. I don't know. It just made complete sense for me. That's I know it's a really simple answer, but it just made sense with my background. It made sense with my way of doing science, and yeah, that was a reason. And challenges, I have to say that I have a really positive experience with this project and during my PhD. I had a lot of support, even if I was not doing the most common type of research. I was really supported, and I didn't encounter so many difficulties, I would say. I think that as long as you don't make big claims and you're humble about your results, I think that's what we all should be as scientists, because we never know. We can theorize and show data, but we'll never actually know. I think that's fine. I didn't encounter so many problems or difficulties, fortunately, during this journey.
Thank you. And I'm sure, I just want to mention too, we do have Sergio Neuenschwander here in the audience, who is a collaborator of Francisco Varela. So if you feel moved to chime in at any point, Sergio, please feel free. I'm sure you have questions, comments, anything along the way. But in the meantime, maybe we can turn to Annie, because I know you've had your hand up for a while, and then we'll.
Yes. I wonder about how about theta waves? The alpha beta waves, but they're theta waves. So where do they fit in?
Yeah, that's a really good question. So the thing with the theta waves is that it's what I mentioned before about the analytical approach, right? They are way harder to detect than alpha beta waves because they normally are a bit more transient. And I know this is a lot of technical detail, but they are so close to alpha that sometimes it's confused to. So they kind of, I wanted to have like a analysis that will take everything into account to give like a really general picture. And we do see some, I'm going to show you. Can I go back to my presentation if you don't, is that okay, Joanna?
Please.
So let me show you that we do see some differences, but they're quite small. In meditators compared to controls, this area here that you see in yellow would be more the theta range. And what we see is that meditators tend to have like this kind of a bit more of quick theta, like around 8 hertz. These waves are related to the monitoring of information. When you're paying attention to something and checking if something is happening, you get this kind of 8 hertz rhythm going on, right? So we do see some changes there. It's just that they are not so strong. And if you want to have a look at theta waves here, you would need to do a different type of analysis. Even for the beta range, you would need some different types of analysis. Now we are working on ways of here in New York of differentiating different rhythms. So what I'm saying to you is like applying other type of analysis, you could see some differences in theta waves, because some previous literature has shown this, right? But the problem is like, previous literature, there are small samples.
Less research because it's more difficult, so to speak.
Yeah, there's less research because it's definitely more difficult. I mean, there are definitely some changes in the theta range that have been reported before. But yeah, I mean, as I said, like the division of waves is also a bit arbitrary. That's why I like to talk about ranges, like between 4 and 8. Okay, we call it theta, but maybe the one at 8 is not the same as one at 4, right? So but if there is any kind of wave that I would expect to be more prominent during meditation compared to a non-meditative state would be a theta wave, and that it's in line with the literature and partly in line with what we have been finding.
I see. And what are you working right now on?
So right now, I'm actually doing here in New York. I'm with Hagen's lab. I'm doing really basic EEG research. I'm still really interested in meditation, and I do have some projects to work on that. But I'm basically trying to figure out what is the best way of disentangling different brain rhythms and how they change. So I'm doing really basic research at the moment because I think that it has a lot of application in different. So my personal experience when doing my PhD is that I thought that EEG was like a super established method that I would just as psychologists go do whatever people do and that's it. And I got more and more interested in the analysis and the methods because there's really no established way of analyzing these signals. And there's a lot of confusion about it. So I'm doing more research on that and really basic cognition, like really basic tasks, and try to figure out what rhythms do what and how we can use in the future this information for improving cognition, mental health. But for that, we need to do some basic research before because we really don't know, unfortunately.
Actually, I just met a French professor who I don't know how he's doing it, but he's been investigating the brain waves of people in near-death experience, but also before death and after death, and the cardiac wave. Are you aware of that guy, Charpier? His name?
No, I haven't. I don't know the work of this person, no, but I would definitely check it out because it's.
Well, if you give me your email, I'll send you.
Yeah, let's do it.
Because it's amazing stuff. It's really serious. He found there's a signal of death, and he can monitor that. Some people come back.
Oh wow!
And some people die, and he said there's a special wave at the point where they can come back. and it's really documenting that it's not, I've seen the curves. It's really amazing. I'll send you that. Put your
Please.
email in the chat, and I'll make sure to send you that.
I will do.
Okay, thank you.
Thank you very much for your question, Annie. Thank you.
Thanks, Annie. And feel free to drop his name in the chat as well, the name of the
Oh, yes. I have to look. Okay.
No problem. Thanks. Yeah, Sergio, why don't you chime in?
Yeah. Hi, everybody. Hi, Johan. Thanks a lot for the nice talk, Julio. I have a question. It's the following. Could you track long-lasting effects of meditation? For instance, that the change you have seen in EEG, they augmented over time with the experience in the meditation. If you improve your capability of, so to say, from naive or, let's say, novice to a more with a meditator with a more experience. Do you see effects that change in amplitude in your analysis?
So we have from my PhD, we had another project that is also published that I can send to you, that was published in the Journal Mindfulness. You can see even like people that go, we had like a collaboration with Singapore, some people that went to a 8-week mindfulness course. But in this sample, we had the people that went to 2 sessions and then people that went to 8 sessions, right? So we had some variability. And then if we would compare, in that case, we were doing like a different type of EEG analysis, but what we saw is that the changes in the people that between the first and the last meditation session of the people that were attending the course more were bigger than the changes of the people that just attended a couple of sessions, right? So yes, we do see some differences in a more continued way. You don't even have to have like 10 years versus 8, 7, 2, and 1, right? You even like between 1 week or 8 weeks of meditation training, you already see some differences in the brain during meditation. I'm not saying that these are differences in the brain that don't make a difference or anything like that. I'm just saying that the EEG during meditation does change when you do some meditation training. That again, if you think about it, makes total sense, right? Because your experience of meditation changes a lot. It doesn't like it after 2 weeks doing meditation every day, you're gonna feel that meditation is a bit different. Right? So we do see.
Perhaps there are really, so to say, plastic effects in the brain that reflects on the EEG composition or the EEG power, the different.
Yeah, I mean, definitely. I mean, there are like changes in the brain like occur every day, right? Like every day, every time you learn something new, every time you experience something new, there are changes in the brain. So I mean, it's funny when you talk to people that are not in the neuroscience field, like, oh wow, the brain changes during meditation. Of course it does. I mean, brain changes with everything, and it makes a lot of sense that you see this difference in meditation. Then we have to assess, of course, whether how these changes are related to something like mental health, or if they are at all, right? These are different questions, but the fact that the brain during meditation changes after meditation practice, I think it's something that we can say.
And the second short question, because Annie Bloch, she mentioned about theta band. Of course, the gamma band is very important in how you think on control of attention, in binding, in this. I understand that gamma is more difficult to investigate in a conventional EEG approach. But do you have any hint or anything in your data that suggests differences specifically at the gamma band?
Yeah, so the issue with the gamma band is that we learned in the last years that we have to be extremely cautious when we analyze this frequency band, because it's really contaminated by muscle artifacts, and it's really contaminated by microsaccades. There's a couple of really good papers about this. So
Yes.
actually, I normally stop at 30 hertz. I know this is a conservative approach, but I'm conservative when it comes to analysis. So to tell you the truth, I didn't even look at gamma because I think that under certain conditions, you can definitely look at the gamma and you can, whether this is actually an oscillation or something else, that's another topic, but you can look at the gamma that comes from the brain. But with EEG, it's just that, yeah, I'm a conservative analyst, so I didn't look at it. I cut at 30 hertz because it's a complicated rhythm, if it is a rhythm.
Yes. Okay, thanks a lot.
Thank you, Sergio, for your questions.
Thanks, Sergio. Thanks, Julio. Sonia, would you have a question, or Matthew? So we have a bit more time still, or even a comment.
Yeah, I'm just it's interesting to hear you say that it's all still very unclear with measuring the brainwaves, because I've often wondered, so God, they must be so incredibly precise, the measurements, because also to detect such small differences between, even after meditating for 8 weeks, and then they can see a difference in the brainwaves. I was always surprised about that, but it's interesting to hear you say that there's still so much unclear. And whenever, sorry?
Go.
It's whenever, natural sciences, they always seem to be so precise, and they get a lot of more funding than the social sciences. Well, that's their reputation anyway, and it's good to hear you say it's actually not so very clear cut as it seems to be.
Yeah, it's definitely not so clear cut, unfortunately. And I mean, I also thought that before study. I mean, I'm a psychology student. I was a psychology student, right? I mean, I come from the social sciences, and then when I went to the natural sciences through neuroscience, I was like, okay, let's go to objective stuff now. And that's definitely not the case, at least in neuroscience. I mean, so the fact that we see a difference in EEG before and after some meditation training, I think that's something that we can report, that we can see quite clearly. Even if I show you the raw EEG data, you might even be able to see some differences. I think that the problem here is, what do these differences mean? Now there's like a huge debate in the EEG, MEG research field, because there was some papers showing that a lot of the effects that we interpreted as oscillatory activity, like brainwaves, they're actually non-oscillatory activity. So non-brainwaves is another properties of the signals that make the signal look like brainwaves, but they are not. We also learned that brainwaves are not perfectly sinusoidal, as I show them in the picture, but that they have like non-sinusoidal properties, and this affects the spectrum. So all these things we are learning now, right? And then I think that it's safe to say there is a change in EEG after whatever, and that's great. But what does this change mean? What is this reflecting? Is it reflecting one area, different areas working together? Is this reflecting one specific type of brainwave? Is this reflecting the interaction between brainwaves? Is this reflecting a brainwave with a really weird shape? Is not reflecting brainwaves at all? Is this reflecting eye movements? Hopefully not. But there is also a lot of effect of something like eye movements in the EEG, right? Muscle artifacts. So there's a lot of things that we don't know. And we are not at the stage yet to say this EEG change means this for sure. Unfortunately.
Okay, well, thanks for that. Yeah, because I remember Alan Wallace. I don't know if you know him. He used to sometimes comment on that it's still so many things are unclear. So thanks.
You're welcome. Yeah, and I want to insist on this. There are so many things unclear, and until science doesn't change a bit, and values a bit more null results, values a bit more sharing data, sharing code, instead of getting like really exciting results and telling people like, yeah, I figured it out, because that's definitely not true. If science doesn't change in that direction, we will never know. So I'm really pessimistic about this.
Okay. Okay, thanks.
Thanks a lot, Sonia. I know Matthew says he's not able to use his mic, so I'm just going to read out his question in the chat here. He says he would love to hear, I'd love to hear Julio riff on the paradoxical findings in the mind-wandering literature. Mind-wandering correlates with impasse resolution in problem solving and depressive anxiety disorders.
Yeah, that's a really interesting question, because when I was expecting something like that, because I made it really simple in the introduction, like, yeah, mind wandering. It was a really famous science paper showing that mind wandering was associated to negative mood, right? It was something like unhappy minds are wandering minds, something like that. I don't remember the title. And it has been shown that mind wandering is associated to negative mood in general, depressive symptoms, whatever you want to call it. Does this mean that every type of mind wandering is bad? No. I mean, it's a bit more nuanced, right? Like, depends on the content, depends on. Mind wandering is extremely useful, right? I mean, we wouldn't be able to live without being able to mind wander, right? It gives us like problem. It's a way of giving solution to problems. It's an essential part of our life, and it's important for our cognition, right? Like planning, if you think about it, you can consider that even mind wandering. So there's a lot of nuance on this. I think that in this regard, you will need a lot of, now there's a lot of experience sampling. So the task that I show you that we do, like asking during the meditation what they're doing, you can do it with your phone. And I know that people in psychology, clinical psychology, are doing this with patients and clinical populations and non-clinical populations to see how mind wandering changes during the day, which type of mind wandering is the one that is actually bad for mental health. So there is a lot of nuance here, and it's complicated, and it's definitely not so straightforward. Like, okay, mind wandering bad? No, it's we'll need more research. I'm not an expert in mind wandering research, but at least what I have read, I'm pretty sure we need a bit more of nuanced about that. I don't know if that answered your question.
Yeah, we got a thumbs up from Matthew.
We got a thumbs up. That's great. That's a good sign.
We also have, I don't know if you know Marika van Voogd, based in the Netherlands, but she's a member of the Mali community. And so she's worked quite a bit on that, and in a particular context of also working with a lot of Tibetan monks. So
yeah, we have met a couple of times. There was a seminar that they organized in Utrecht that I went to a couple of times. She was quite inspiring during my PhD, because she did really a lot of cool work regarding mind wandering. Also, like, she has like more of a computational background, so she had a lot of modeling and really cool stuff. Really cool stuff. She's really inspiring researcher. Yeah. So,
were there any other burning questions or any other comments or even other ideas? Because I know you opened up the floor at the end to maybe asking for some feedback too about new directions for this research. So if there's any comments about that too, that could be interesting just to hear the collective wisdom in the room.
Yeah, I think it's also difficult to know is the way to go, right? I think it's a bit. I decided to go more in the fundamental research based on the little consistency that I saw. But of course, there's a lot of really cool work regarding this neurofeedback thing. I don't know how useful it will end up being. If you will need like a device to learn how to meditate, I don't know if it's useful at all. I I found the idea interesting, but we need to see if this is useful in the future.
I would maybe just have one last, question about just precisely about that, because you mentioned a form of neurofeedback that would offer a stimulus at a certain point to then remind the person to refocus their attention on the object of attention.
Yeah.
I'm wondering too about these more, I guess, popularized forms of neurofeedback that people use for therapeutic purposes, where you have a constant background stimulus, such as music or some visual, watching some sort of film, and you have these thousands of micro interruptions that correspond to some sort of variation in the brain activity. And I'm thinking about how that's also been used very much kind of like a meditative technique for people to get benefits, but without the sort of more internal training associated with that. I don't know if there's much literature out there on that particular approach, or what you think about that in terms of the potential and how similar that might be to the findings you're getting from mindfulness training. Because it seems there are some parallels.
The funny thing about the mindfulness training and there is some evidence of health benefits, right? The things that we don't know exactly which is the factor that leads to the health benefits, right? Maybe if you get to a similar state through a different technique that cannot be considered meditation, or what? Meditation is a word, but what you're saying, through a really different techniques, through like watching or listening to something, and you get to a really similar state, maybe a state of sustained low arousal, like some activation of the parasympathetic system that would be beneficial for you. Maybe you get the same benefits. Maybe now there was, I think, a study showing that just slowing down your breath does already involve some health benefits, right? Like reduce anxiety and depression. So is it like only the breath that it's leading the positive effects? Is this the low levels of arousal that you reach during meditation? What is it? I mean, it doesn't really matter what it is, right? As long as it is, we see that it's useful for people and for their health, right? If listening to a repetitive tone between 20 minutes every day, it's more beneficial for you. Maybe it works better for you. Maybe the meditation it's not for you, right? I would like to know why. What is the factor that drives the effect? But for purely translational, from a purely translational perspective, it doesn't really matter, right? Whatever works. I have a question here
From Matthew. So I'll just read it out so we can all hear it. Any thoughts on the dynamics of rhythmic coupling in group meditation, thinking of how setting affords different attentional capacities, particularly in the context of the neuromodulation of attention?
What you mean by rhythmic coupling is these studies that also became kind of popular in the last years, that this shows some coherence between people, right, in their brain waves. I don't know if just to make sure I'm understanding what you're saying. Yes, okay, another thumbs up. So I got it right. I have never done, like, they call it like inter-subject synchrony, something like that. I have never done that type of analysis. I've read papers about it. Obviously, if I'm skeptical of what happens in the brain in one subject, imagine how skeptical I am about the coherence between the brains of different subjects. So I'm obviously really skeptical about it, but I'm also not an expert in that type of research. There are a lot of factors that can also explain this brain coupling between subjects, including like movement or similar movements, or also reaching similar states. We don't know, but I'm definitely not an expert in that field. I don't know how robust is the evidence of group synchronization, group brain synchronization during meditation. so I don't think I can tell you a lot about it. And the second part?
The second part was thinking about how set or setting affords different attentional capacities, particularly in the context of the neuromodulation of attention.
I'm not sure I understand this question. Yeah, I guess you're talking about like how meditation can be just an attentional training, right? How can improve attention? What we talked about neuroplasticity before, there is some evidence showing that meditation practice improves some basic cognitive capacities, such as sustained attention, but the effect seems to be quite small. But there seems to be some evidence for that. I can think of, if you want to improve attention in a specific population, you can, of course, give it a try with neurofeedback, with meditation. There's some neurostimulation. I don't know if you're aware of it, but there's some neurostimulation protocols that would allow to enhance specific brain rhythm, hopefully to improve some sort of cognitive capacity. But again, this is still, I would say this kind of research is in its infancy. Pretty interesting stuff going on with neuromodulation techniques, and I think one day we will be able to improve cognition through neuromodulation. One day, we are not there yet, but I think we will be able to do that in the future.
Okay, thank you, Matthew, for both of those great questions. All right, are there any more questions in the room, or?
Yeah, what is neuromodulation?
Yeah, so neurofeedback can be understood as neuromodulation, but it's basically techniques that allow to change your brain activity. So, for example, there are some neurostimulation techniques. So there's a kind of a coil, an instrument that generates a magnetic field, and this interrupts the electrical activity on your brain for some seconds, or it can train it. So this would be like a neuromodulation technique. Another one would be, I just use a extremely low amplitude electric current to go through your brain, so it doesn't harm you, but hopefully it can train some of your brain rhythms, so I can improve them, right? So I can make it more prominent. This would be like, for example, transcranial alternating current stimulation. It's a TACS. That's one other. So these are just techniques that have been developed in the last years, and that allows you to change brain activity. And the idea behind this is like, okay, if we can change brain activity, maybe we can improve cognition, or maybe we can do some sort of rehabilitation of. So this is, this is neuromodulation in short. You also have the one I told you about, the neurofeedback, can also be considered neuromodulation, because you are also changing your brain activity depending on the stimuli you receive, right? For example, let's say I show you in a screen a bar that changes depending on your alpha power, like this brainwave that I told you about before. And then I ask you, try to make the bar as high as possible. You will try to figure out a strategy to maximize this type of brainwave in your brain, right? So this is also neuromodulation. It's just that you are doing it instead of a machine doing it, right? But it's still neuromodulation. Is it clear?
Yeah, I think good.
Thanks, Sonia. Julio, I'm wondering if there's any last comments or reflections you'd like to offer, just based on what's been said and sort of what you offered us this evening in terms of the state of the current EEG research. Any other last comments? Or
I think my my conclusion would be, let's be cautious when we interpret changes in EEG. Let's keep doing fundamental research. Let's keep doing applied research. Let's share our data, our code, and let's be collaborative, and let's do open science. And lastly, I encourage young researchers to apply for this kind of grant, because in my personal experience, my personal experience was great, and I think it's a great experience for a researcher to think about what they really want to do when they are like 23 or 24, and end up doing it. So I will encourage, of course, young researchers to apply for this kind of award. And yeah, that's it. I hope I was clear and not too pessimistic about the state of the art in the state of EEG research, but it's great.
Great. Well, thank you. And I think that, your message overall is it's inspiring too, for sort of the next generation of scientists who are interested in a neurophenomenological approach. So thanks for this, once again, this opening into the field, but also into your specific research project, and for sharing your time with us this evening. And so best of luck with your continued research. And just to close the evening, I'd just like to announce a couple of upcoming events that are public. The first of which is a public event everyone is welcome to follow on the YouTube channel. And the second of which is an Emily Friends series for Emily Friends subscribers. So this is very much related to what we've just been talking about in terms of the tradition of Varela and neurophenomenology. This semester, we are doing a close reading of the embodied mind. And so we're on session 5 already, chapter 5 of the embodied mind. And so we'll have Dr. Giuseppe Pagnoni, who is a neuroscientist as well, giving a lecture next Tuesday evening on chapter 5, emergent properties in connectionism, which is followed by an hour of discussion. So that'll be on the Emily YouTube channel next Tuesday. And then next Thursday, we have an exclusive Emily Friends talk from one of our philosophers at Mind and Life Europe on inaction between theory and practice. So both of which are continuing in the inactive tradition. So looking forward to seeing many of you soon. So thanks a lot once again, Julio, and thanks to everyone who joined us this evening.
Thank you very much, Hannah.